with C programming, there was something that we saw in the last part of this lecture. So let us just pick it up from there. So there was one problem with the quadratic equation solver that we created. The major issue was that it was not really a solver that could solve all quadratic equations. It was basically a solver which was solving one particular equation where a was 1, B was 3, and C was minus 15. So it looked like something like this, right? This was because we actually fixed the values of A, B, and C at the beginning of the program. Now let us just first try to make this program more generic, right? Generic as in something that can solve all the quadratic equations. I mean, of course, those with real roots. And the second thing was that that output that we saw, right? It was a bit ugly because right after the output, the prompt, the prompt of bash was showing up. So at least we should try to get the prompt on the next line so that the output is clearly visible. So this is the second thing that we would like to do with that initial program that we created. Let's just try to make that equation solver a bit more generic. So we'll create another version of this program. Let's call it generic quadratic equation with the real root solver. We'll make two changes here. First of all, we are going to use another library function called scanf. This function, just like printf, it is another library function which is used for input output. Printf is used for showing certain text to the user. Scanf is used for taking certain inputs from the user. And we are going to use a special character in the message strings that we are going to display, and that special character is \n, okay, which essentially means new line. So this is the generic equation solver. This is how it looks like. No, this is the first statement that you can see. It is having something that is very similar to the printf statement, but instead of printf, it is actually scanf, right? So now printf function is used for printing messages on screen. We can specify certain kinds of format specifiers. We thought we had a look at two format specifiers, %d and a %lf. So with the help of those format specifiers, we can actually create a very well formatted string. Scanf works in almost the same fashion, but the role is reversed, right? So instead of instead of printing something on screen, scanf is used for uh, getting inputs from the user in a well formatted fashion. Okay, so this is very important. The well formatted part is very important here, right? Printf is a function that you use to prepare a kind of string where, as you remember, we were giving these format specifiers and the actual values of variables were getting pasted there by printf. So similarly, scanf expects the user to type a message which contains specific values, which are the input values for our variables, and it also expects discipline from the user. So similar to printf, where your message is kind of, you provide a template, and then in that template there are placeholders where the values come up. Similarly, scanf also expects that user is going to type the message in a certain fashion, and within that message there will be certain places where it is going to find the values for your variables. So this is a simple example. It says scanf a equal to %d, b equal to %d, c equal to %d. So essentially what it expects now is that user is going to type something on the shell which looks exactly like this, but instead of %d, it will be a value, right? So scanf expects user to type something like this, right? A equal to 1, b equal to 2, c equal to minus 15. So keep this in mind, that the user has to type it exactly as it is, right? So there has to be a, there has to be equal to, there has to be an integer, then a comma, then a space, then b equal to another value, comma, space. So everything has to be exactly like this. So this is what scanf expects. Scanf expects the user to provide input in a very disciplined fashion, right? And there is one change that you can see here. It is, in comparison to printf, that before the name of the variables you have these ampersands here, right? So for now, just uh, uh, accept these ampersands to be a part of scanf syntax, we will actually look at what these ampersands mean in the later weeks. So this is the generic version of the equation solver. Now we are printing some message. It says that please formulate your equation in the form of ax square plus bx plus c, then provide the values for the parameters in this particular order a, b and c, and this is an example. So essentially I am expecting the user to type the values in exactly this fashion. So what will happen is when you will run your program, there will be no output, but the cursor will start blinking at this point. Okay, so as if it is expecting you to type something. So now when you type something like this, a equal to 1, b equal to 3, c equal to -28 and press enter, then you will get the output, right? And this is the output. This is the these are the roots for this particular equation, right? And you can now do it for multiple equations, right? So here I have changed the inputs and I have got the roots again. So basically now this whole generic equation solver has become this equation solver has become generic. So because a, b and c are inputted by the user, now you can basically solve any quadratic equation with real roots. And the other thing that we have done in this is basically made our strings more pretty. So for example, in the previous version the prompt was starting right here, right? But now it has come to the next line. And not only that, there are certain messages that we have printed here with the help of printf, and they are appearing on different lines. So how did we do that? Well, you actually need to add a special character in your messages, and this special character, even though here it looks like two characters backslash and n, it is treated like single character. When it is stored or whenever it is interpreted, it is actually treated like a single character, and we call it backslash n or simply slash n in short. So this backslash is essentially what is known as an escape character. Okay, so what is an escape character? Essentially what it means is whenever printf or scanf are actually going through the string that you have just given them, as soon as they encounter a slash, they escape from the normal processing. So normal processing of printf would be expecting that this particular string is supposed to be displayed as it is. The normal processing normal processing of scanf is where it is expecting the user to type a string as it is, but as soon as they actually encounter a slash, from there on for some time, okay, for some time the processing mode changes. Okay, so essentially whatever is lying right after backslash, they actually check it, and then based on that their behavior changes. This is the idea of an escape character. Okay, so now not every character can appear right after backslash. Okay, so n is an allowed character. Similarly, another character that you can use is t. So if in your string you can use backslash n as well as backslash t, both are allowed. You cannot just randomly put any character after backslash, right? So there is a fixed set of characters which you can use. They are known as escape characters, and so this is exactly, by the way, backslash t is equivalent to a tab space. So if I put a backslash t here, when printf will process this particular string, instead of typing t as it is, what it will do is basically it will create a tab space. Okay, now tab space could either be 4 spaces or 8 spaces depending on your environment, but the idea is that as soon as printf will see backslash and right after that there is an n, this whole thing will be interpreted as a new line character, right? So it will change the line and go to the next line. And these are not the only characters, by the way, which you can use. There is, as I said, a fixed list of them. There is a homework related to that, so just have a look at it. So basically this backslash n character is used in C wherever you are trying to print a message and you want the print message to go to the next line. Now there was one more discussion that I had left in the previous part, and this was like where exactly shall we use these parentheses and where we should not, right? So there were two examples in that lecture. in the first one I was not putting any parenthesis, and in the second one I am actually using two pairs, right, here as well as here. So what exactly are these? Why is it that in one case I am using parenthesis, but in the another case I am not doing that? So we have to figure out why this non-uniform usage of parenthesis, right? So the idea is that in the first example, I actually don't need them. This is the idea, right? You can still put parentheses there. It's not a problem. You can put, for example, b square, b into b in a parenthesis, and similarly 4ac, 4a and c inside another parenthesis. But as I said, it is not really required. Okay, but in the second case, it is actually required. So if I remove these parentheses, the interpretation of this particular line would actually change. So this is why it is a slightly more complicated. Now in arithmetic you would have known something like BOD mass, right? So bracket, and then what is this, division, multiplication, addition, subtraction. So essentially you would have read that the first thing that you do in an expression is division, then you do multiplication, then addition and subtraction, something like that. Now in computers, especially in programming languages, things are slightly different, and C is no different from them. So what we have in programming is that there is something known as precedence of an operator, right? So the precedence is essentially the priority with which a particular operator is evaluated with respect to the other operators. Okay, so this is very important. If in a particular expression you just have one operator, then precedence doesn't matter. But if you have multiple operators, then there is a hierarchy between these guys, right? So there is certain guys who are higher, and there are certain guys which are lower, and the actual priority is basically depending on and this is fixed, by the way, right? So it's not like you can decide upon it. It's a fixed priority for each and every operator, and these operators are evaluated as per their precedence. Okay, and so if you have a particular expression which has more than one operators, the operator with the highest precedence is evaluated first, followed by the operator that is next in precedence, so on and so forth, right? And it will happen many a times that two operators will actually have exactly the same precedence, so in which case the operator on the left is evaluated first and the operator on the right is evaluated later. So essentially we will actually start calculating from left to right, and if all the operators have exactly the same precedence, we'll calculate the left ones first and then the right ones. Okay, so basically parenthesis is the operator. Okay, parentheses are also an operator in C, and they have the highest precedence, and because of that I can actually use parenthesis to actually group up computation, right? So if I want certain kind of computation to be done first, I simply put it inside a parenthesis. So parenthesis can in somehow override the the normal precedence in which the expressions would have been evaluated. So this is why parentheses are used when I want a very finely controlled evaluation of an expression. So this is a very simple example. Let's say I have this particular statement, d equal to b into b minus 4 into a into c, and let us just try to see how it is evaluated. So essentially, there are three different stars here, asterisks here, which are basically multiplication, and there is a minus and there is an equal to. So by the way, equal to also is an operator. So there are a total of 5 operators here. I have just numbered the stars so that you can understand what they are. So now what you have to understand is this asterisk, right, or star has higher precedence than the minus. So this is in some way similar to your arithmetic, that addition will happen or subtraction will happen after multiplication has already happened. But unlike arithmetic, it's not like division has a higher precedence as compared to multiplication. No, division and multiplication are basically the same, at the same level in a programming language like C. So this is why I had to include those expressions inside parenthesis, because otherwise there was no guarantee which there was, I mean, not, it was guaranteed which would have been calculated first, but I wanted it to actually be calculated in a different fashion. So anyhow, so basically star has higher precedence than minus, and minus has higher precedence than equal to. So this is now what happens is something like this. Within the stars, right, so within the asterisks, the asterisk 1 operator is going to be evaluated first, because this evaluation is going to go from left to right. So essentially what happens is something like this. um, I'll just show you the final result. So what happens is, this is a way to look at it from the perspective of parenthesis, that the first thing that will be evaluated will be this particular asterisk 1, because this has the highest precedence, as well as this is on the leftmost side, right? By the way, equal to is on the leftmost side, but equal to has precedence which is lower than both asterisk and minus. So the first thing that C would look at is the precedence. So precedence of asterisk is higher, but now it will realize that there are three asterisks, and which asterisk to evaluate first. So the first asterisk, okay, from the left gets evaluated first, then the second, then the third. So basically this is how the evaluation will take place. First this b asterisk b is calculated, then 4 asterisk a is calculated, and then whatever is the product, it is multiplied by c. So now you have this particular term evaluated, and then finally this minus has higher priority than equal to. So then this minus this is calculated, and basically this is what I wanted, right? I mean, this is exactly what I wanted, so I don't actually need to put any parenthesis here. But in the other case I did actually need parenthesis, so that is why I had used it. So and after all this computation is done, equal to, because it has the lowest precedence, what happens is whatever value comes out here, it gets assigned to D. Okay, so now there is some homework. This is very, again, the homeworks are going to get more intense, so please have a look at them and do them sincerely, because a lot of learning would actually lie in the homework part. Okay, so okay, thank you, bye.